producing a single stereoisomer in a controlled manner is very important, as it can add great value to the molecule. For example, a single enantiomer can be 5 to 10 times more expensive compared to a racemate. So what strategies can be used to gain stereo control over reactions? Well, the first is substrate control. This is where one portion of the molecule, known as the substrate, has stereochemistry that can influence the introduction of stereochemistry into another portion of the same molecule. So here, because the blue alcohol attacks the green carbonyl, the stereochemistry of the alcohol dictates the stereochemical outcome of the reaction, forming the acetal, with 99% EE control. The product is minus Frontalin. The next strategy has similarities with the substrate method, and that is the auxiliary strategy. This still involves a single molecule, but a section of the molecule, called an auxiliary, has been added to the key portion of the molecule that ultimately is retained. The ratio of substrate to auxiliary when the auxiliary is added is greater than 1:1 with more auxiliary. And remember, the auxiliary is probably expensive as it's a single enantiomer. This is done exclusively to control the stereochemical outcome of a subsequent reaction. Then, this auxiliary portion of the molecule is removed. The 8-phenyl methyl ester section of the molecule in blue is the auxiliary. It controls the approach towards the reactive carbonyl in green of the Grignard reagent by blocking, through steric repulsion, the back face attack, only permitting the Grignard reagent to attack from the front, thus dictating the stereochemical outcome of the ensuing alcohol. Next, with the auxiliary having served its purpose, it's removed, and the alkene is exposed to ozone and converted into a ketone that's then ready to carry out the acetylation discussed just now in the substrate-controlled reaction example.